Welcome to Excel and Finance video number 3. Hey, if you want to download this workbook and follow along, click on my YouTube channel, then click on my college website link, and then you can download the workbook, Finance and Excel Chapter 00. If you're in the class, just go to our class website. Hey, in video number 3, we want to talk about math symbols, and then we want to talk about the order of operations for calculating formulas in math and Excel. Hey, we're going to have to use lots of parentheses in this finance class. Exponents, caret, which is shift 6, multiply, which is asterisk on the number pad, most convenient, / is division, add, subtract. We may even have to use comparative operators. We already use equal sign to create a formula because equal sign is the first character in the cell, and that tells Excel that you want to do a calculation or a formula. But you can also use an equal sign, which we'll see in this video, as a comparative operator. You can ask the question, is this thing equal to this other thing? Here are some other comparative operators. Important to notice that greater than and equal to, less than and equal to are two characters next to each other. It's not like in math. Not, which probably won't get to use in this class, is those two symbols. And join, which we probably won't get to use either. All right, let's see some math examples. Adding, we already know by now, this is the third time we'll see this. Alt equals. What does alt plus equal sign do? It is sum. So don't even chance it. You know, sometimes people want to go like this for a small one. But I'm sorry, that takes longer. And if for some reason you did a structural update like we saw in our last video, that formula doesn't work. Alt equals. And it guessed right. So now, last couple videos I've been hitting enter. But if my goal is to create formulas and go to the side, I do not put the formula in with an enter. I use tab, the tab key. Subtracting, I'm going to say equals. Now, I'm going to use my arrow keys. Remember we talked about last video, you can use your mouse or your arrow keys. I'm going to click escape. Arrow keys are much faster when you're close in like this. So I hit up arrow twice, and then minus, and then up arrow once. I'm going to hit tab. So we get -3. 2 minus 5, -3. All right, dividing. Important thing about dividing, equals, up arrow, division, up arrow once. Notice this is called the numerator, and this is called the denominator. This is the top. This is the bottom. If the top, the numerator, is bigger than the denominator, the number will always be greater than 1. The opposite is true if I make a formula where the numerator is smaller than the denominator. This number will always be less than 1. If they're both the same, then they're 1. So that's division. Multiplying, there's we could do this times. Use the asterisk on the number pad and then get that. However, similar to the sum function, if we have a bunch of things we're multiplying, you can use the product function. Whoops. Product. The word product means, in math, that's the answer. The product, 6 times 6, the product is 36. So you can highlight like that. I don't think we'll get much chance to use this. We'll usually be using the multiplication symbol. I hit tab. Exponents. Now we're going to talk about the whole sheet over here about we're going to talk about exponents. But just an exponent. If I take 6 squared, or 6 with an exponent of 2, equals 6, and you have to do shift 6. That's a caret symbol. That's the exponent symbol in Excel. And that means the base is 6, and the exponent is 2. That means take the 6, repeat it 2 times with a multiplication symbol in between. So it's 6 times 6. Again, we will have a bunch more examples of exponents in just a moment. Now, let's look at a comparative operator, because a few times in this class we are going to have to make what are called logical formulas. They don't give us a number answer, or they don't give us a word answer like text formulas do, which we don't do a lot in this class either. But logical formulas, occasionally we will do them. We'll need to ask the question, make a formula. So we type in equal sign, then we want to say, is this equal to? The equal sign is not the first character. That tells Excel I'm a formula. This is a comparative operator. So this formula says, is this equal to this? And this is very important sometimes because we may have discrepancies which we can't detect because it's so far out in the decimal place. Now, a logical formula or true-false formula only has two results. It's either true or false. Now, before we investigate why those aren't equal, let's do another one. Equals is the value in M3 greater than the value in M4? Well, it better say true. Yeah. Now, let's go over here. Almost always, and this is actually extremely common in Excel, because number formatting can disguise the number. And we'll talk about this in a video coming up. But right now, let's just investigate this. Now, if you click in the cells, you can look up in the formula bars and tell that there's a difference. It means that somehow that decimal is hiding. So on the surface of the spreadsheet, our eyes see 10, 10, and we immediately say, oh, the accounts are in balance or something, or the two dollar interest amounts are the same. But what's happening here? Well, in this video, we're just going to see how to increase the decimals. Now, we added a decrease the decimal. I'm going to come over to Home. In our first video, we saw how to add buttons to the QUAT. Now, notice what's nice about the Quick Access toolbar is if we use increase, decrease decimal, or borders, or font color all the time, it's convenient to add these. So I'm going to come over here. Oh, I can't even see this, so I'm going to have to come to the side and expand. Click the Home, and I'm going to right-click Add to Quick Access Toolbar. In fact, I think I'm going to do a few more. I'm going to, well, anyway, not now. For now, we got those two. All right. Let's go ahead and use it. Let's increase decimal, and if you point your cursor and you can't figure out which one is which, the screen tip will come up. Increase, increase, and then where we can see, in fact, what was happening is the number formatting, this is called number formatting, was disguising our numbers. Guess what? And this is one of the most common mistakes in Excel on the planet Earth. People think that what they see is actually there, and it's not. And that's why this formula is so good, because it'll never get tricked by formatting. It never looks at the formatting numbers. Formulas don't look at the number format. They look at the underlying number, and that's why that formula told us there's a problem. So if it was a problem, we would now know that they're not equal, right? If they were interest amounts and we're saying, OK, this is the greater interest amount. If it was a mistake, then you'd go ahead and fix it like this was actually a 0 or something. And then it would immediately change to true. I'm going to Control Z because those are, in fact, different. All right, we got to go look at order of precedence. Now, please excuse my dear Aunt Sally. In finance, we have big, huge formulas that we're going to do. A lot of times, we'll have functions like PMT and FV and PT and rate and all these great built-in Excel functions that will do the big formula calculations for us. However, even though there's some cool functions, there's still some big formulas we're going to have to create. And if we don't know our order of operations, or in Excel, there's something called order of precedence, which we don't get to cover in this class. But here's the complete list of everything of how Excel calculates formulas. So if you download this, you can see that comparative operators are way down at the bottom, right? All right, so let's ask this question. All our question is 2 plus 2 times 3 raised to the second power equal to 144? Or is 2 plus 2 times 3 raised to the second power equal to 20? Which is it? If we didn't have these order of operations, people all over the planet Earth would be getting different answers, right? All right, I'm going to just take a guess here, wild guess here. I'm going to say that it's 144. OK, so here's my logic. 2 plus 2 is 4. 4 times 3 is 12. And 12 squared, which means 12 times 12, is 144. Right? So that's what I think. I'm going to try this. Excel knows the order of operations. And got lots of great questions over the years of people saying, how come Excel's not working? It's not calculating right. And it's really that the person doesn't know their order of operations, just like me right here. I don't really know my order of operations. I'm thinking that the order of operations is left to right. But lo and behold, when I type it in, when I hit enter, Excel will give you the right answer. User error here. If I really wanted to go from left to right, I would have to do something completely different, meaning I'd have to know my order of operations. All right, so in this case, it's not. The order of operations is do everything in parentheses first, then all exponents, then multiplication, division left to right, and addition and subtraction left to right. Now watch this. Really what happens, there's no parentheses, so we skip on this one. There's an exponent. So what's 3 squared? That means 3 times 3. It's 9. All right, so we get a 9 there. And then we do multiplying next. Well, so 2 times 9 is 18. And then finally, we do our plus and minus. 18 plus 2 is 20. So sure enough, it did. Excel gave us the right answer because Excel knows this order of operations. Now, sadly, many of Americans don't know order of operations. So here's the deal. There's only 4 things, so go and memorize it. Now, I'm going to copy this. Now, here's something cool. We'll get to see this in a couple of videos coming up. That little thing in the corner there is called the fill handle. When you move, this cursor right here is called the selection cursor, right? But if you move your cursor right near the fill handle, you see that black crosshair. Bill Gates calls it a crosshair. I like to call it an angry rabbit. If you click and drag, it'll copy the formula. All right, now I'm going to change this one, and we're going to make it 144. If you really want the 2 plus 2 first, that's where the parentheses come in. I put parentheses right here. Okay, that'll force that one. But then I need to force the multiplying next. So I have to put another set of parentheses. And notice what Excel does. This is cool. It gives you a color coding. I wish that worked when I drew it on paper like that. So now we have a color coding. The black ones are on the outside. Well, wait a second. When I hit enter, that will show the correct color. Here, here's a keyboard shortcut. Control Enter puts the formula in the cell and keeps the cell highlighted. And now I'm going to hit F2. And now you can see for a moment there it wasn't showing the right color. But when I F2 to put it in edit mode, the green ones are calculated first, and then the black ones, right? So 4. And then the 4 times 3 is 12. And then the 12 raised to the caret 2, or raised to the second power, is 144. Now, let's learn how to evaluate a formula. If you go up to the Formulas ribbon, Formula Auditing, and then Evaluate Formula. Oops, that's off to the side. Uh-oh, my video has been off the screen this whole time. Formula Auditing, and you can't see it. It's off the screen, so I'm going to scoot it over here. Formula Auditing, Evaluate Formula. It'll open up this dialog box, and you can click Evaluate. And this will show you exactly how it calculates 4, and then 4 times 3 is 12, and then 12 caret 2 is 144. All right, so the lesson here is you got to know your order of operations. So if you don't know and you're in the class, just 4 things to memorize. There's our 20 right there. I know that was off the screen. That's too bad. All right, order of operations. One last topic, exponents. All right, we talked about this just a moment ago. If I take 2 raised to the 6th power, this is a reverse of the one we did before. The base always means that's the big thing. The 6 means repeat, that's the exponent. Repeat the big thing, the base, 6 times and put a multiplication symbol in between each one. So 2 times 2 times 2 times 2 is 64. Here's the example of calculations we'll be doing when we get to cash flow analysis, discounting cash flow analysis, chapters 4, 5, 6, 7, and onward. We'll have formulas like this, where we have a 1 plus the annual interest rate divided by the number of compounding periods per year raised to the compounding periods times total years. That whole thing we'll have to calculate. So not only will we have to do exponents, but we'll have to know our order of operations. Exponents. also in this class, we're going to have square roots. And square roots, there's a function in Excel called square roots, which we'll look at in just a moment. But there's not a root function where we can do the 5th root and the 6th root and the 7th root. These two examples are square roots and how to express them. You can express a square root as 2 raised to the 1/2. But if it was the 5th root, you would have to be 2 raised to the 1/5. And we'll see an example of that in just a moment. Exponents, when you have a situation like this, x squared divided by x squared, you know there's one thing divided by the other, so that means it's just 1, right? But in exponential denotation, you take the 2 on the bottom and you bring it up to the top and put a minus sign in between, and so you get x raised to the 2 minus 2. So that means anytime you see x to the 0, you know it's 1. So x to the 0 is going to be 1. Again, if you have an x to the 3rd divided by x to the 3, you could think about it this way. Cancel, 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 and what's left is an x. But if you do it in exponent notation, you bring the 2 up here, and you take 3 minus 2. So 3 minus 2 is x to the 1, which of course is just x. Finally, x, anytime you say a negative exponent, means you take the big thing right there and just put it underneath. Even if it's x raised to the minus 10, you take the x to the 10 and put it underneath a division bar and 1 on top. So it's really the inverse of whatever it is. So x to the 1, when you see a negative 1, it means takes the inverse of x to the 1. Inverse just means put a 1 and a slash and then whatever the thing is underneath. All right, let's see some examples here. 2 caret 6, that should be giving us 64. So I'm going to say 2 and then caret that's 6, and we should get 64. Let's go ahead and do this factor over here. We don't need to know the meaning of it. We're just practicing the math of it. All right? Equals, and then 1 plus, and we take our annual rate divided by our number of periods per year, close parentheses, and then caret. And now in math class, we wrote it like this, and we could get away with it. We could just put the exponent right next to the parentheses, make it small and up and little small and up like this, and then just write 12 times 30. And everyone knew to calculate it correctly, but that doesn't work in Excel. And the reason why is because the order of operations. If you do, multiplication is commutative, which means you can do it in any order. 12 times 30 is the same as 30 times 12. But I'll keep it the same here. 12 times 30. The problem here is that it'll do everything inside of the parentheses and then the exponent next. So because multiplication comes after exponent, and we want it to come first, we have to go like that. We have to say, hey, no, 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 do that multiplication before the exponent. So really, the last thing calculated in this formula is that exponent. If we do formula evaluator, I'm going to click evaluate, and you can see it's calculating everything inside that first parentheses first. There's the plus. It gets that right there. Now it's going to do everything inside of there. Okay, and finally, the last thing it does is that exponent right there. All right, and exponents. Square root, I mean. And what we want is the square root of 16. Now, what does square root mean? If you say, what's the square root of 16, what you're really asking is what times itself equals 16. Well, if you know your multiplication table, you know it's 4 times 4, because 4 is the itself part, right? So what times itself equals 16. So 4 times 4 equals 16. So here's how you do it. You go equals whatever that cell is, caret, and then we have to, in parentheses, 1 divided by 2. Right? That's the longhand way. Now, when we're doing square roots, and in chapter 11 or something we have to do square roots, we can use the square root function. And we'll learn about that there. And that's just because square roots are pretty common, right? But there's, if we have to take the third root of 8, which means, and I wrote it up here, if you say the third root of 8, which should be, I don't have it written out, it should be like this, 8 caret 3. It means the what times itself 3 times equals 8. Well, 2 times 2 times 2 is 8. So the answer should be 2. So, but how do you do a formula for this? Okay, the base is 8, caret, and then in parentheses 1 divided by, and I'm going to click on this 3. All right, and that should tell us 2. And the reason why is because 2 times 2 equals 8. All right, exponents. One last topic in this order of operation and math symbols. We got to talk about the number 1. The number 1 is a magic number. Anything divided by itself, anything divided by itself is 1. 43 divided by 43, 16 divided by 16, whatever. X squared times y divided by x squared times y is 1. In this class, we're going to do financial statement analysis, and we're going to do lots of ratio analysis and something called DuPont analysis. And we'll see things like assets divided by assets, which means we're looking at the balance sheet and we're going to see the total asset amount. So what is it? What's asset times assets? Usually we only do numbers. Well, anything times divided by itself is 1. And so in this class, we will see, debt divided by equity, assets divided by net income, or whatever it is. Sometimes we will see this strange setup like this. And just realize it's 1. Anything divided by itself is 1. Look at this. 1 raised to any number is 1. 1 raised to 10,000 or a million is 1. 1 raised to any exponent, right? Or any root here, equals 1. So 1 has an interesting characteristic. Here's one. We'll see 2 examples right now of the use of 1. When we get to chapter 3, I think it is, we'll do assets divided by equity, which gives us our leverage. That means how much debt. It's a measure of how much debt we have. And we'll learn that assets equals all the debt plus all the equity. So we can have this calculation right here, d debt plus equity, d plus equity divided by equity. Well, we can break that apart because we're doing addition and it has a common denominator. So we can say d over e plus e over e. And immediately when you see this, you realize this is a thing divided by the same thing. So we can convert it to 1. And it's very convenient in our ratio analysis to do that. But it all stems from the fact that anything divided by anything is 1. And then, of course, if we have our debt to equity, we can just add 1, and immediately we will know our assets over equity. Another important example of the number 1. This is for percentage change formula. And we're going to have lots of these in this finance class. Let's imagine our stock on January 1st is 98 bucks, and on December 31st it's 102.50. And we want to figure out what is the percentage change. Well, we're going to call the end value, that's the one at the end, end, and the begin value, begin. All right, so the percentage change formula is, now this is the long way, and I'll show you both ways in a video coming up. And this way is a lot longer. But if you know the number 1 trick, we can change this. But here it is. You take the end minus begin, which just gives us the difference, right? 102.50 minus 98. That's the change. It went up, right? If it went down, it would be negative, and it would indicate a reduction in value. But there it is. That's the change in the numerator, and you divide it by the begin amount. So in this case, it would be 102.50 minus 98, end minus begin, divided by 98, and that would tell us the percentage change. But look at this. That's a subtraction. And this is a common denominator. So we can take this and take end divided by begin minus begin divided by begin. Immediately when we see that, we say 1. And in statistics and finance, this is the formula you use for calculating percentage change. Very rarely do you see this. This is what you usually see. And it's because we know anything divided by anything is 1. All right, so that's just a little bit about 1. We'll see those actual calculations coming up. In our next video, we have to talk about the ever elusive and troubling number formatting. If you know about it, it's easy. And then we'll talk about percents and a couple other topics. All right, see you next video.